Hi friends, welcome to the channel Friend for Maths. This is our first video and this is the part 1 video of chapter 1, the real numbers. And in this video we can discuss the topic Euclid's division lemma theorem and its algorithm. Before going to that main topic, we can discuss some basic points. What are they? The factors of a number, different types of numbers, and HCF and LCM of two or more numbers. What are factors? Factors of a particular number are those numbers which are exactly divides that number. Exactly divides means the remainder will be equal to 0. That is, we can take an example here, the number 4. The factors of number 4 are 1, 2 and 4. What it means? When dividing 4 by 1 and when dividing 4 by 2 and when dividing 4 by 4, the remainder will be equal to 0. That is, these numbers 1, 2 and 4 is exactly divides the number 4, and these numbers can be called as the factors of the number 4. Here the 4 is the factor by itself. That means every number will be the factor by itself. Next, the different types of numbers. There are prime numbers, composite numbers, integers, real numbers, rational numbers, irrational numbers and whole numbers. First, just imagine a number line with 0 at the center and infinite positive numbers in the right side and infinite negative numbers in the left side. And we can take some number in the positive infinite position as infinity and in the negative infinite position as negative infinity. Here, the real numbers are all the positive numbers from 1 to infinity. All the positive numbers, okay, from 1 to infinity. And whole numbers are all the positive numbers from 0 to infinity. Okay. Next is prime numbers. Prime numbers are those numbers which has only two factors. These numbers will have how many factors? Only two factors. One factor will be 1 and the next will be the number itself. That means here we can take the example. Here 2 has only two factors. What are they? The number 1 and 2 itself. And 3 has only two factors. The number 1 and 3 itself. And in case of 5 also, it has only two factors, the number 1 and 5 itself. For 7 has two factors, number 1 and 7. Like that, the prime numbers have only two factors, the number 1 and that number itself. Next is a composite number. Composite numbers are those numbers which have more than two factors. Okay, more than two factors. Next, the number 1 is neither prime nor composite. Next is integers. We just imagine that number line with the positive numbers at the to the infinity in the right side and negative numbers to the negative infinity at the left side and 0 at the center. And these integers are all these positive numbers, 0 and the negative numbers from negative infinity to positive infinity including 0. And these integers can thus called divided as positive integers and negative integers. Okay. Next is a rational number. Rational number is a number that can be expressed as a fraction in the form p by q. That means a fraction is the expression of a number in the form p by q, where p is called as the numerator and q is called as the denominator, and in this case the p and q will be two integers and q will not be equal to 0. Such numbers which can be expressed as a fraction in the form p by q, where q is not equal to 0, are called rational numbers. These are the examples. Next is the irrational number. Irrational number will be then what? That is a number which is not rational. That means the irrational numbers cannot be expressed as a fraction in the form p by q with integer values in the numerator and denominator. Here are the examples. Next we can discuss the HCF and LCM of numbers. What is HCF? Highest common factor. Okay, we can go directly to an example. That will be easy. That is taking HCF of 12 and 16. To find the HCF of these two numbers, we are first listing out all the factors of 12 and 16. Like this, 12 has factors 1, 2, 3, 4, 6 and 12, and 16 has factors 1, 2, 4, 8 and 16. And from this we are taking the common factors. Okay, here there are two common factors. What are they? 2 and 4. And from these common factors we are taking the highest one. That is the HCF, highest common factor. In this case there are two common factors 2 and 4 and the highest one is 4. So the HCF of the numbers 12 and 16 is 4. Okay. There is another method to find the HCF of two numbers. Here first we are taking the largest number. When given two numbers, we have to find out which is the largest one, and that largest number is dividing by the smallest number. Then there will be a quotient and a remainder. And if this remainder is not equal to 0, we are again dividing the divisor of this stage by this remainder. That is 12 is dividing by 4, and there we get another quotient and the remainder. And if the remainder is equal to 0, we can stop this process. Like this, we have to continue this division till the remainder is getting 0. In this case, in the second step, we have got the remainder equal to 0 and we are stopping this process and look out the divisor. Divisor in the last stage will be the HCF of the given two numbers. Here 4 is the HCF of 12 and 16. Next, in case of three numbers. Okay, HCF of three numbers. To find the HCF of three numbers, first we have to find out the HCF of first two numbers, and to obtain the HCF of these two numbers, we are again finding HCF of this HCF at this number. Okay, let's do. We are first finding out the HCF of 10 and 35. Okay, 35 is the largest number, so it is dividing by the number 10, and we are getting quotient as 3 and 5 as the remainder. Here 5 is not equal to 0, so we are again dividing this the divisor 10 by this remainder 5, and we are getting the quotient 2 and the remainder equal to 0. Thus we can stop here and look out the divisor. What is that? 5. 5 will be the HCF of 10 and 35. And to find the HCF of these three numbers, the last step is find the HCF of this 5 and this 50. Hope you understand. That is, we are going to find out the HCF of this 5 and this 50. Okay, that is 50 is dividing by this 5 and we are getting 10 as the quotient and remainder is equal to 0. So we can stop here and look out the divisor, that is 5 itself. So the HCF of 10, 35 and 50 will be the last divisor, that is 5 here. Okay. Next is least common multiple. To find the LCM of two numbers, there are two methods. In first method, we can list out the multiples of each numbers like this. Here, the multiple of 3 and multiple of 4 are listed out like this. And from this, the common multiples are selected. Here, 12 and 24 are the common multiples. From this, we are selecting the least common multiple. That is the lowest common multiple. Here from 12 and 24, it is the 12 is the least common multiple. Therefore, the LCM of these two numbers 3 and 4 is 12. In case of three numbers, we are doing this process. This method is called prime factorization method. Here we are going to prime factorize these three numbers. For that, we have to take any prime number which will undergo any two numbers. Here in 36 and 60, the prime number 2 will go. That is, for 18 times and 30 times, and 45 has no change. And again 2 will go in 18 and 30. 9 times and 15 times, and 45 has no change. Next we can take the prime number 3. 3 will go in these three numbers for 3 times, 15 times and 3 times. Again number 3 will go in these three numbers for 1 time, here 5 times and for 1 time here, and no further factorization. So we can stop here, and the LCM of these three numbers will be what? The multiple of these prime numbers, that is 2 into 2 into 3 into 3 into 1 into 5 into 1, that is here equal to 180. We are going to the first topic, main topic of this chapter, that is Euclid's division lemma. This is very simple. That in this it is says that when we are taken any two numbers of our choice, there comes a relation. That if we are taking the numbers as first number as A and second number as B, then there comes a relation that A will be equal to BQ plus R, where R is greater than or equal to 0 and less than the second number B, where Q is the quotient when dividing this A by B and R will be the remainder when dividing A by B. This is applicable for any two numbers. Okay, there are some examples. In case of 17 and 6, 17 is the A and 6 is the B. So we are applying the equation A equal to BQ plus R, like 17 equal to 6 into 2 plus 5. Here 2 is the quotient when dividing 17 by 6 and 5 is the remainder when dividing 17 by 6. Next is 5 and 12. Here A is 5 and B is 12, and we can write as 5 equal to 12 into 0 will be the quotient when dividing 5 by 12, and 5 is the remainder when dividing 5 by 12. Next is 20 and 4. 20 equal to 4 into 5 plus 0. 5 is the quotient when dividing 20 by 4 and 0 is the remainder. Like this, for any two numbers there comes this relation. That is the theorem here. Given positive integers a and b, there exist unique integers q and r satisfying the equation a equal to bq plus r, where r is the greater or equal to 0 and less than b, where q is the quotient and r is the remainder when dividing a by b. Okay. And also there comes an algorithm. In this algorithm, it says that to find out some properties of numbers, we can use this Euclid's division lemma equation a equal to bq plus r in a step-by-step process. That is means algorithm. Okay. So first, to obtain HCF of two positive integers, that are two positive integers here taken as c and d, and here c is greater than d. That means to find out HCF of two numbers, we have to first find out the largest number, isn't it? So here it is given that c is the greatest here. So in this method, to apply the equation, we are taking the largest number in the a position and the smallest number in the b position. Okay, here in this algorithm, in the first step, to find the HCF of two numbers, we are applying the equation like this: a equal to bq plus r, where a is the greatest number and b is the smallest number. Here c is the greatest and d is the smallest. And in this step, if this r is not equal to 0, we are going to the second step. That is, if r is not equal to 0, then if the r is equal to 0, the d will be the HCF. And if the r is not equal to 0, we are again applying the division lemma to this d and r. Okay, that is this second number and the remainder. Otherwise, if the r is equal to 0, we can stop here, and the HCF will be the second number, d. Or if the r is not equal to 0, we are applying the division lemma equation again to this d and r. And in the third step, we are continuing this division till the remainder is getting 0. And the divisor at the last stage, where the remainder is equal to 0, will be the HCF of the two numbers. We can go through the steps. Here is an example taking these two numbers 455 and 42. Okay, taking a as 455 and b as 42, and 10 will be the quotient and remainder 35. 35 is not equal to 0. So what we have to do, or we have to apply the equation to this 35 and 42. And taking 42 as a, 42 equal to 35 into 1 plus 7. 1 is the quotient when dividing these two numbers and 7 is the remainder. So again, in this step also, the 7 is not equal to 0. So again we have to apply the equation to this 7 and 35. And that is, here 35 equal to 7 into 5 plus 0. Here the remainder is equal to 0. So we can stop here, and the divisor in this stage 7, that will be the HCF of these two numbers. Okay. Okay, we can stop here now, and we can discuss the problems related to this topic, Euclid's division lemma and its algorithm, in the next video. Till then, please subscribe this channel and click on the bell icon. Don't forget that. And please share this channel with your friends. And if you have any doubts and suggestions, you can mail me at friendformaths@gmail.com. Okay, then take care. Bye.